In this video, we will be looking at ellipses and hyperbolae. Ellipse singular, hyperbola singular, hyperbolae plural. Okay, so how's an ellipse defined? Well, let's begin with the usual equation. We have x squared on a squared in Cartesian coordinates, x squared on a squared plus y squared on b squared is 1. Here a is greater than b, that's the orientation of it. This is the semi-major axis. A is a semi-major axis, B is a semi-minor axis. In this particular case, the definition of an ellipse, how it's defined, is let P be any point on the ellipse, and it's always true to say that the distance PF1 plus PF2 is a constant. So this distance plus this distance is a constant. You actually do this activity, you get a bit of you draw up your own axes on a bit of cardboard, attach a pin F1 and F2 which are the same distance apart from the y-axis, pick a string of any particular length you want, then put a pen inside it, and you could draw around like that. You draw an ellipse. Move the pen around and the string will constrain you to draw an ellipse. Okay, here F1 and F2 are the focal points of the ellipse, and for A greater than B, okay, semi-major axis oriented horizontally, not vertically. So A is the semi-major axis, B the semi-minor. For A greater than B, the foci are at plus or minus the square root of A squared minus B squared for the x value, and y equals 0. Swapped around the other way if you wanted the ellipse in a vertical direction. Okay, now in general, let's transform this ellipse away from the origin, and so similar to the circle, you could write it as x minus h if you've shifted h units right, all squared over a squared, semi-major axis length, plus, if you want to lift it up, y minus k all squared over b squared, the semi-minor axis, is equal to 1. And the centre in this case would be at hk. Okay, so I mean, knowing that, it can be quite easy to sketch an ellipse. Even if my sketch looks awkward here, you get the idea that the centre is going to be at 3, 16. Okay, x is 3, y is 16. Okay, a is 2 because you've got a squared. B is 8 because you've got b squared there. Okay. Okay, now let's have a look at hyperbole. Okay, we'll start with a hyperbola. Okay, the thing about the hyperbola is that we've now got x squared on a squared minus this time y squared on b squared is 1. Okay, if you were to, the asymptotes will occur at x equals plus or minus b over a on x. All right. And here, and this will always be the case, these are your asymptotes and the parabola approaches those values. Okay, you can see the center is 0, 0. In general though, if we were to transform this, if we were to shift it right and up, then we'd have x minus h all squared over a squared minus y minus k all squared over b squared is 1, and that's with the center at hk, so shifting it right, shifting it up. Of course, you're going to shift it left, you're going to put plus h, and if you're going to, or you'd have minus minus h, so it becomes x plus h. Okay, and similarly with the y value. Okay, so the center is hk, and the equations of the two asymptotes are given by y minus k is plus or minus b on a times x minus h. Okay, okay, if you were to now, that then I think that covers everything I wanted to do with that. Okay, now, that's the other thing I want to do, yes. Here it is. Now, if we now reflect the hyperbola, whose equation is given by x squared on a squared minus y squared on b squared equals 1, about the line y equals x, Okay, we get the hyperbola whose equation is y squared this time, over a squared minus x squared over b squared is 1. That still has centre 0, 0, and it has asymptotes at y equals plus or minus a on b times x, whereas before we had b on a. And if you just come back to this one, if you reflected about the line y equals x, you can see that you're going to end up with branches up the top. Okay, so instead of having so here's our asymptotes again. Okay, this time we're going to be something like this. Okay, something like that. Okay, and that's just a reflection about the line y equals x. I think there, just have a look at that, we can see okay, I don't think there's anything else I want to add to that. Alright, so that's your introduction there, done.